Name is Beth Moseng, and this is my presentation, Settle the Score, CVSS Fundamentals. We'll be going over just the basics of everything just about CVSS, because a lot of times people know that the score exists, but how do you get that number? Well, that's a big question. One of these days the clicker will work. Oh. So who am I? Well, first things first, I've been programming for 8+ years, and I've been working somewhere within the cyber community, learning about all of that for about 6 years. I'm also an avid enjoyer of Magic the Gathering and a flautist in a video game flute choir for that extra little spice. And then my professional experience, I have been with Lockheed Martin since 2019 through a bunch of different teams. So I was developing on the MFU team, working a lot with RF from 2019 to 2021. Then I was transferred over to their DICE team, doing a lot of incident response and working in that area from 2021 to 2022. And now I'm currently working with offensive cyber operations, where I do a lot of development for the actual cyber community, which is pretty cool. And then, and then I also have a bachelor's in computer science, graduated as of yesterday, and you can see a bunch of smiling faces. So, very busy weekend for me, as you can tell. And so now the start of it all, CVE and CVSS, you know, a bunch of alphabet soup, and of course there will be a lot more acronyms to go over as we go on, and we'll be rushing through those. So what exactly is a CVE? Well, actually, it's CVE is common vulnerabilities and exposures, and that is the entire list of all of the exposures. And typically, if someone refers to a CVE, they mean an entry inside of, you know, the CVE. But, you know, semantics, everyone knows what you're talking about when you say it. And so what exactly it is a publicly documented security flaw found in some sort of code base, like exploiting a buffer overflow that leads to code execution, you know, all of that little fun stuff that us hackers get to do. It is maintained by MITRE, as you might know from the MITRE attack framework, just a fun little company there, and it was established in 1999. All of these are stored in a lot of fun places like the National Vulnerability Database, which is maintained by someone in the government. And CVEs are given out by CVE numbering authorities, and a bunch of different companies are CNAs, where you can have one from, let's go with Lockheed, Oracle, all of those places that maintain software, and then they get assigned a number of CVE IDs that they can assign throughout the year. So if you see a bunch of numbers close together from a certain company, it's not because someone found a flaw right next to each other in that same company. It's just because they have that block of numbers to use. And then here's an example of a CVE ID number. The log-J4 attack is the one I'll be using for just kind of the example when going over the intro. And log-J4, as you know, was the one where everyone's Minecraft got hacked, including your Minecraft. And how it goes is it's CVE, then the year that it was found, and then the number assigned for the CVE ID. Now, what qualifies for a CVE? It needs to be independently fixable. So, for example, if it is something that you need to fix it by fixing about 3 different other bugs, and that's not just a CVE. You need to be able to just fix that one patch, and then you're fine. It needs to be acknowledged by the vendor or well documented. And so either like the person that developed the software needs to say, hey, this is a problem, or someone needs to come out with documentation saying that this goes against the security policy and that it impacts the actual usability and security functionality of the code. And then it also needs to be affecting one code bases. If a CVE affects multiple different products, then you would get a CVE number for each different product that it affects. And then if a code base would have to, if there is no way for the bug to be fixed without fixing that one different code base, and that code base is using a bunch of different products, but the only reason that it is combined like that, then it would have a specific one CVE for that multiple different products, but that's a rare case. And so what exactly is CVSS now that I've kind of defined and gone over the basics of CVE? Well, it stands for Common Vulnerability Scoring System, and what exactly it is it's just kind of a measure of severity of a different exploit or exposure. It was owned and managed by FIRST. FIRST stands for the Forum of Incident Response and Security Teams, and it's been maintained since 2005. And then over on the left, you can see kind of like the difference in ratings between CVSS version 2 and CVSS version 3. CVSS version 3 has a lot more difference than just how it's rated. We'll be going over that a little bit. But as you can see, the higher the number, the more severe that it is. And then at the bottom of my bullet points, you can see a bunch of letters. Those will make sense later on, but I just wanted to show an example of a written out CVSS score. And so that way then you can actually qualify it or quantify it. Now, how do they relate? I know that this talk is about CVSS, and you guys are all very intrigued in CVSS, but it relates to CVEs because most CVEs are assigned a CVSS score, and just having a CVSS score without actually knowing the thing that it's attached to is pretty useless. Like, oh, hey, something got assigned a 10. Cool. What was that something? And so the CVE kind of gives you that context for what it is. It also shows it shows the severity of a specific documented CVE so people can accurately identify the threat level of different exploits. So a brief history of version updates. CVSS version 1 was created in February of 2005. The first release was found to be pretty buggy, so they updated to CVSS version 2 in 2007. And then, of course, again, nothing with its first release patch is going to be perfect. So users needed too much knowledge of vulnerabilities for CVSS version 2 to be accurate. You're never going to know everything that's going on inside of an exploit. And then for CVSS version 3, it needed a bit more clarification, but not an entirely new formula change. So they came out with CVSS version 3.1 in June of 2019. And that's what's pretty widely used today. Some places are still using CVSS version 2, but typically the scores aren't too far off, but there were a lot of differences in some being a bit scored too highly in CVSS version 2. Why is this important? Why is CVSS something that is used in a lot of places? Well, first, it's free and open, so free and open that I was able to make an entire PowerPoint on this. But also it's not proprietary information. I can use this inside of my company, someone else can use it inside of their company, and it's a way for everyone to be able to accurately communicate the different severity of different flaws. Like, it doesn't matter if I am scoring something between 17 and 203, because we all know that someone out there is going to use arbitrary numbers to score something. You are able to have the same number compared between different companies, so that way everyone can accurately have a communication, have communications between companies to talk about these kinds of threats. So it's extremely important to have good and open communication between companies. And then stripped directly from their website, CVSS was designed to provide open and universally standard severity ratings of software vulnerabilities. And it's just great to be able to have an open conversation between companies. So what makes up a CVSS score? This little snippet is directly from their CVSS score calculator from their website. You can click the little categories, and then when you do that, it tells you what score it's going to be. And then here you have all of the different metrics that something with CVSS is defined by. So, you know, with the attack vector, it's either going to be network, the adjacent network, local, and physical. We'll be going more into depth about the specific categories later. But I just wanted to show a little bit big of a picture. So that string of letters that I showed you guys earlier that I'd say I'd be going more into depth, this is where you get all of those values, where you would say attack vector N, and then the next one you would say attack complexity, let's go with L. And then here is that string at the bottom with the Minecraft tag. That is just that way you can see where I was getting those letters from. And so now I'll be going into depth what the different metrics mean. So first, with the exploitability metrics, you have the attack vector, and this is the level of access required to exploit the vulnerability, meaning whether you need to be physically at the computer or just across the network or locally there. And so it's kind of where you need to be in the context of the exploit. Then we have the attack complexity. It factors out of the attacker's control to exploit the vulnerability. A low attack complexity means that all of the factors needed to exploit it would be inside of the attacker, so everything they need to do is within their hands. And a high complexity means that they kind of need to wait for specific circumstances or those kinds of things. The privileges required, as you can probably guess, is just whether or not you need admin privileges or what kinds. So none would be, no privileges required, maybe a guest account. Low would be any common user, and then high would probably be admin. And then we have the user interaction, the necessity of a willing or unwitting participant to succeed. So either someone clicking on that link that you told them not to click on in the phishing email, or someone downloading a file that they really shouldn't have, or it can be someone physically at the computer saying, oh, I hate this company, they fired me, I'm gonna help this hacker exploit some malware, and you have that man inside. So none would be no user interaction, and then required would be any one of those situations. And now we have impact metrics. And I know for all of you that have either studied for or got your Sec Plus, the CIA triad's going to look very familiar to you. But you have the confidentiality impact, and so it's the amount of data that the attacker gains access to. And then, none, low, or high, all of those three are the same for these three categories. And then you have the integrity impact. It's the ability for the attacker to change the physical data. And then you have the availability impact, which is the ability to change the accessibility of the data. So I guess changing privileges, probably executable, but anything of where you're changing the availability. And now we have the scope metric, either changed or unchanged. The scope is if this exploit can propagate to other components, like leading to more exploits being used. For example, if I'm able to get a certain hack inside of a computer, does that open the door for me to be able to use a bunch more, or is it kind of a one and done scenario? So all of those metrics before were just for the base score, and that's what is next to any sort of CVE because it doesn't change. These are two other scores that you can have, where I won't be going over these too much in depth, but it's the temporal and environmental, and the temporal score kind of adds to the base score, which are metrics that change over time, like if an exploit is a lot more severe when you first learn about it, or if it over time it becomes maybe more documented and wow, it's a lot more worse than we thought. And so this is how the score would change over time. And then the second one is environmental, which is factors that change from person to person, like maybe your level of antivirus software or your operating system and that kind of thing. So it's the severity of the attack based on each person. And you can't exactly just slap this score onto every CVE because it changes so often. So these two aren't as widely used than the base score. And now here we go into a case study where I go a little bit of dipping my toes into vulnerability exploitation and showing my thought process while using my knowledge of CVSS and what the scores mean to think, yeah, I could do that. I could totally do that. So my first thought was, let's look at the top 10 exploits in 2022. What all happened? There was the obvious ones like Log4Shell, Spring4Shell, and like the Chrome 0 day, but everyone has done a talk about that, so I wanted to do something that maybe wasn't as widely known. And on PurpleSec's website was CVE 2017-1182, and I saw that an exploit from 2017 was still extremely widely used in 2022, and that was pretty interesting to me. Like, how is that still viable 5 years later? So I was like, yeah, sure, I'll check this out. I have nothing better to do. So what exactly is it? It's a bug in multiple versions of the Microsoft Office Service Pack that allows an attacker to run arbitrary code in the context of the current user by failing to properly handle objects in memory. What does that mean to some people who don't know what that means? Well, The Microsoft Office Service Pack is handling data in a way that it shouldn't be, and that leads to you being able to redirect of what code it should be executing next and injecting your own code inside of that. So instead of running the next line, you're now running whatever hack I put into it. And in my case, it was running, I think, the command line. And over on the left, you can see the picture, just a physical picture, because I know that blob of letters below probably doesn't synergize with everyone. So I saw that you needed to be local, and well, I'm local, I have my computer, I can execute that. The attack complexity was low and the privileges required were none, and both of those appealed to me because that is something that if exploited could be pretty dangerous, because you don't need any privileges or extraneous circumstances to do it. And it does need user interaction, but it's mostly just the user needs to click on the thing that you want them to, unwitting or wittingly. The scope is unchanged, and that didn't matter to me as much because I was just kind of seeing if I could run this on my computer. And then the cool part is that it impacted all of the confidentiality, integrity, and availability on a very high level, which appealed to me. Because if this is a simple attack that I could do, and it has this amount of data change and access, then that's pretty rad. It had, through all of these things, it had a base score of 7.8, which is pretty high. And the reason that it wasn't, perfect 10 was because of the scope being unchanged, the attack vector needing to be local, and the user interaction needing to be required. So trying to test the exploit, after about 30 seconds of searching on the internet with the Google search parameters being just the CVE ID, I found a GitHub link. And as everyone knows, GitHub's pretty cool. Guys, I love GitHub. The contents of this repository was not only a README with extremely well documentation. There were comments everywhere that I needed it to be. There was an entire exploitation script in Python where you just kind of needed to run it with the commands, with the different command line arguments, with the extremely well documentation that it gave me. It was great. It also had debugging instructions with specific breakpoints where if it didn't work, hey, here's where you go to look. Extremely well documented. It was great. The hacker community wants you to hack others. It's so... So here are the steps taken, very riveting. I downloaded the script. I ran the script with the instructions given, so just the very few command line arguments. It created an executable, and then I clicked on that executable. Very riveting, very obviously difficult. I'm kidding, this was very easy. Does it work? Long story short, yes, but I have Windows Defender, and Windows Defender really wants to help me, except for when I'm trying to create a presentation about exploiting my computer. Short story long-ish. Oh. I swear that there's more to my presentation. Short story long, after realizing that my Python version was wrong. Remember, kids, Python 2 can save lives. Quite literally, all I needed to run was the exploitation script. Hey, not hey. All I needed to run was the exploitation script the way that it was telling me to, with saying cmd.exe, that's the executable that I wanted it to run, with the output file of the name, and then I run the output file. And then, of course, Windows Defender deletes the script and then gives me the little fun pop-up. It's doing its best, but that does mean that I was trying to do something that I shouldn't have been, which I count that as a personal victory. So connecting it back, that was a very simple exploit for me to do. I showed you the steps. I showed you why I thought that I'd be able to do that. And it worked enough. It worked enough. But if my system wasn't patched for it, I would have been able to impact the security on my device to a very substantial amount. As I've said before, it had very high scores for confidentiality, availability, and integrity of data, which was pretty interesting to me. So here are the takeaways. Windows Defender, it's pretty good. I don't think I have other antivirus software on my system because I already knew Windows Defender does not suck. Hackers make it very easy for people to get their hands on potentially dangerous software. Again, 30 seconds of Googling gave me the exploit script that I needed to run that exploit. And knowing why something has a high CVSS score can save a lot of heartache. It had very easy steps for me to take through, and I thought that I could do it because I read the information that was easily given to me, and I used it to the best of my ability. And I was able to succeed and give this talk to you all. So thank you. My name is Beth Moseng, and you can follow me on the Twitter account that I don't use and just made so I would be able to put it on this presentation. Thank you. Any questions? Yes?
Hi, Beth. My name's David. Thanks for the talk.
Yeah.
From a defender perspective, I know there's some critiques of the CVSS system as a whole.
Mm-hmm.
I know at my firm, we've been trying to layer on KV on top of that and to get more nuance. What would you say are some of the top critiques of the CVSS system in its current formation? And any advice for defenders?
The top critiques is that it still just is a score. There isn't as much documentation of more of the specifics. Like, yes, it says user interaction required, but does it mean that someone just needs to arbitrarily click it or someone needs to knowingly do it? Essentially, it just doesn't have as much details as it probably should have. Other critiques probably is that it does change over time, like through the different version updates between CVSS version 2 and CVSS version 3. Like, you have to be specific when talking about it of what you're doing. And there's still probably other bugs with the current system that they're still trying to fix just because it isn't a perfect system. Nothing's going to be perfect, and I'd say that the best part is probably just being able to have a baseline communication with other people. Mm-hmm. Am I good to take more questions, or?
I think you have room for maybe one more, and we're going to have to call it.
Cool. Chris? Sorry.
Chris Badger. Wonderful talk. Thank you very much. So the question I have is, in your opinion, how useful is the CVSS scoring system? In other words, you explored a couple of different vulnerabilities that are very well known, and so it's very easy to evaluate the quality of the score. Have you taken a look at, say, more junk CVEs and their CVSS scores, and how well do those CVS scores accurately reflect, I guess, the relative uselessness of certain CVEs?
I haven't taken as much time on some of the smaller exploits, but as I've kind of mentioned before, that for the smaller, I'd say it's probably the lower that you get in score. For example, the lower numbers, maybe anywhere from 1 to 4, it gets less important of what the actual score is, just because it's either a lot harder for someone to implement or because there's less data that's being changed in that kind of aspect. But even scores with low scores still have an impact, or else they wouldn't have a score in general, just because they are an exploit. So I'd say, while understanding what the score is for some of the smaller exploits, it still is good to treat most as a potential threat, just because of the idea that it still is an exploit and it still has the potential to do harm to your system. So even if it doesn't seem something as impactful, it still has the potential to do greater things. Thank you.